Me start recording. Good. So today we are going to talk about pig and pigletin. Before we do that, do you have any questions related to the four sessions which we have covered, where we covered Hadoop's architecture, we covered MapReduce, we tried to model MapReduce using Java. Also, we learned how to convert any problem into MapReduce problems. Okay. How do we convert general logic into MapReduce? So we walked through multiple kind of MapReduces. We also talked about how to use Python streaming and also the testing of everything. So we covered a lot related to MapReduce and advanced MapReduce. So if you have any questions now, you can ask before we move further. No questions? Good. All right. All right. Cool. Good. Good. So if you have any questions related to MapReduce or advanced MapReduce or Hadoop architecture, feel free to drop an email to hadoop@nobigdata.com. Okay. So Hadoop at nobigdata.com. Okay. And we are almost there with respect to launching our own forum where we will answer questions on the forum itself. And you can see the answers over there. All right. So every question related to the big data technologies will be addressed on the forum itself. All right. So there is no format as such to upload assignments, and in the future the format is going to be in the format of a quiz where you can answer your questions in the quiz itself. Okay. Even the pig Latin assignments, the text, I'm planning to put it as inside the quiz itself rather than in the Google Docs. Okay, but Google Docs makes it easy for a complex subjective answer to be discussed line by line. Okay, and that makes it very easy. So the general idea is you create a Google Docs. General idea is that you create a Google Docs. Just a second. I need to turn off the phone. All right. So you can basically create a fresh Google Doc as in the document, and then you can share it with me, or we can make it just share it with anybody with a link. All right. Anybody can view and comment with the link. That should be good enough. All right. Because out of all the documents which I've seen, Google Docs is probably a pretty good one, which facilitate live talking, live chatting, as well as if it facilitates line by line debugging your problem. Okay. So for example, somebody in the session was having by mistake had written BT instead of BY. Okay. And I had replied that can you look at this? So it was a quite a big confusion over the emails to just pinpoint that exactly what I'm talking about. So that is one problem which I find very convenient with Google Docs. But nevertheless, We'll be moving on to something called subjective questions in the quiz itself. And there you can either answer then and there, or you can paste a link to your Google Docs, okay, or any other docs which can be viewed without any login password. All right. So can you share access to the Hadoop server for deployment purposes? I did not get that. Do you mean that you require administrative rights for Hadoop? Sanjay? Okay. So basically, you can just log in with your students. So I think there is some bit of confusion. Let me just remove that confusion. Okay. So we have got under my courses, you will see your course only. Here there are too many courses I'm part of, and you can click on the in the first session. The installation instructions contain all of the information requires is required. All right, so all you need to do is SSH using a login called student, and that should be good enough. Okay, and to copy the jar to the Hadoop machine, all you need require is use SCP, or again there are multiple other solutions. Okay, you can use now, other than SCP, there is a version of Putty which helps you in that. Okay, so here you can see the login password and all, and then you can log into these servers. All right, so is that what you're looking for, Sanjay? All right, great. Moving on. Good, good. So today we are going to discuss something about pig. And why do we need it? We'll start with that, and then we go deep into the implementation. Okay. So pig is essentially an engine to execute data flows in parallel on Hadoop. So, and pig tries to be not only for Hadoop but for all other systems also. They're working on something for Spark as well. So pig basically a new kind of query language which looks like SQL but has a few more added advantages over SQL. Okay, we'll go into those details. So Pig is essentially the whole framework, and Pig Latin is the language per se. And the Pig Latin basically provides various standard SQL kind of filter operators such as join, order by, filter by, limit, and all those things. Okay, we'll go into the details. Pig runs on Hadoop and HDFS, and it can load the data from anywhere you wish. It can load the data from HDFS, it can load the data from MySQL, it can load the data from HBase. Okay, so and how does Pig Latin looks like? Okay, let's have a look at what is. Look at this. So this is a very simple word count example what we had been discussing since the day zero. Okay, so let's just see. First line is load the data as line by line. Okay, so this is my input which contains lots of lines. Now after this line basically generates one word per line. It does a tokenize and then flatten and then iterate away. We go into the detail. So this is a full text loaded line containing multiple lines. And word, when we say input equals load this file, we say next statement is word equals tokenize my input, which means that each line, so words is basically now a list of one word per line. Okay. Now after that, we just group by the words, group by words by group words by word, each word, and there we are. Okay. We can just after that we can just count each one, group it and count it. So if you notice in standard SQL, we'll have these two statements in a single line. Here they are split into two. You group it first and then iterate over it and then count it. Okay. And once you are done with counting, you just print it. So even if you do not understand a single line out of this example, do not panic. Okay. The idea was just to sort of give a overview that hey, this is how pig Latin looks like. Now next time you look at similar statements here and there, you can quickly say, hey, this looks like pig Latin. All right. So this is how pig Latin looks like, and you're right away the interaction mechanism between you and the pig framework is this pig Latin. So pig basically executes pig Latin, and that's the only meaning of pig to you. Okay. So we will go deep dive into pig Latin. Okay, because that's what it means to us. All right. So pig Latin is a data flow language. Data flow as in data went from file into lines, from lines to our words, and from words to our count groups, and then from groups to our counts. Okay. Now pig Latin is basically a data flow language where it helps us how the data flows from source till the destination till the point we get a results. Okay. It also allows us how is the data going to be read, how is the data going to be processed. It allows us how it is going to be stored to multiple outputs in parallel. Okay, it gives us, as opposed to the SQL, it gives us a finer control over optimization. Remember, most of the big data works are all about optimization, because big data problems cannot just work. I mean, you cannot solve big data problems without even a smaller optimization. Okay, you will have to always, because a slight change in your plan can make the big data handle impossible. Okay, handling big data might become impossible, a slighter change in your execution. Okay. So in one of the projects, when I did a little bit of hurriedly, I did not plan too much, so I thought that our RAM should be able to handle. And just because of one small thought that our RAM should be able to handle, I ended up more than 20 GB RAM. Okay. Till the point RAM was 6 GB required, it was okay. We had that much servers, up to 8 GB servers. But the moment it went beyond it, it just bulbed. It just went useless. So a minor optimization can save your life when you're dealing with big data problem. And therefore any programming language or any framework which is truly made for big data handling is should be helping you with optimization, and so is pig Latin. Okay, it helps you designing your complex workflows. Yes, it is helping. So no, actually. So when I solved my problem from 6 GB, 16 GB, and we had only 6 GB, I did not increase RAM from 6 GB to some 20 GB. Instead, I just tweaked my program such that it consumes less memory and does lot of work in the disk. That's what I did. Okay. So so that way, so what I'm trying to say is that minor mistake, minor optimization can take you from impossible to handle data to uh, to be able to control it, to be able to handle it. Okay, and therefore, Pig provides you all kind of controls, all kind of knobs, which with which you can optimize it. Okay. It is not very opaque to you. It's not like a very big black box that this is how it is done. Even if little unoptimized, it's okay. No, it helps you. uh, It gives you control so that you can optimize it. Okay. Now, all right. Let me just make it a little more bigger. It helps you design your workflow such that you can join multiple inputs, you can split the data into multiple streams, and lot of the work of parallelization can be done by pigletin by itself, but you can aid pigletin by helping it decide number of parallelisms. Okay. Also, it doesn't have any loops other than for each. It doesn't have any if conditions. Okay. Now let me just compare Pig Latin and SQL. Although these comparisons do not help beyond, you know, being able to talk, but let me just compare it. So in Pig Latin, users describe exactly how to process the input data. Okay. While in SQL, you tell that, hey, I want this, and SQL does it for you. And underneath what's going on in SQL, you have no clue about. Okay. And the only way you can figure it out is by seeing the plan. But in SQL, you basically are very target oriented. You are very end objective oriented. In Pig Latin, you go from this is my data, this is what I'm going to do about it. So that's a general psyche. I mean, you won't find much of a difference now unless you look at the language. Okay. So Pig Latin contains each operation, the operation as in whole, each operation is basically a long series of data operations. The each objective say I want to convert this data from this to this. Okay. This process is not a single query, it's a chain of queries. It's a series of data operations. While SQL is always a single query means the whole thing executes and gives you output, right? If you wanted intermediate step by step, you would have to save it in temporary table, or I mean, doing a set based operation was also not very helping. Okay. I mean, if you have to do a sort of little more complex thing, you will be stuck with the, I mean, you will end up with very complex queries. Okay. Because one query gives you the whole output. Here, you define a multiple steps. And in step by step, when you do something step by step, your whole job is actually fairly uncomplicated rather than a single query. All right. Now, SQL was designed specifically for the cases where you had clarity on the data. The table was very clear. There was no doubts about the structure of the data. Every data is was in the form of tables. There was no hash tables, there was no objects, there was no objects in the hash table, or arrays inside the hashes of objects. Okay. So that kind of situation wasn't there in SQL. everything was a table, right? And all the logic we have to do was with respect to thought process that our data is in the format of tables, and all we can do is join from one place to another. While pig latin is more like given a set of object or complex set of objects, how do you transform them from one form to another? Okay. And this is designed for generally Hadoop kind of a systems where the data can be in any form. It can be in plain text, it can be CSV, it can be tab separated, it can be complex objects. Okay. So that's pretty much with differences between Pig Latin and SQL. Okay. Now, as we had been handling MapReduce in the recent past, you must have realized that writing MapReduce jobs requires a bit of wizardry, requires a bit of coding, and it might get on your nerves when it starts repeating things. As in, every time we have to join two tables, we have to do this and that. We have to form two mappers where the key is here and key is there, and you end up writing a lot of codes. If you had tried to solve those 4 or 5 problems, you would have been this writing map reduces again and again could have got on your nerves. All right. So, because every time, most of the things you think, okay, this is a grouping thing. I just wrote the same thing for the previous problem. Why can't I just utilize that? So, so the birth of Pig Latin happened just for that reason. Because lot of, you have to write a lot of code. You had to do repeated task again and again. Second, MapReduce doesn't really know much about your data, so it doesn't give you the information about your data. While in case of a Pig Latin, you have a clarity. In the first few statements, you form the clarity and definition of the data, and then you operate upon it. Okay, so and most of the things like join, filter by, group by, order by, union, where you require a lot of map reducing, it is already there, right? Remember our last problem, that voting problem? Every time, if you try to think about it, there are two chains of map reduces, and you get lazy that, okay, I can't do it. It'll require too much of efforts. That's where that's where the pig Latin comes into play. The pig Latin will make your life really, really simple. And trust me, none of you are going to look back. All right. So that is about a comparison between pig Latin and MapReduce. The only problem with Pig Latin is there are some tasks which are a little bit out of the way, tasks which are difficult to be handled by a standard mechanism. Remember our DNA problem where we wanted the key to be in this manner. To do that kind of thing would require a bit of if conditions, bit of other reversing the strings, right? Those are not readily available in pig. Maybe now they're available, but that will again, you will have to do your custom user defined functions in Java. So inevitably, when you are anyway going to use Java, why don't we write MapReduce upfront in Java? Okay, so that is the only reason you might look back at MapReduce, but most of the time you will be happy with your Pig Latin when you have to churn the data. Okay, partitioner, combiner, all of those are sort of implemented in Pig Latin. All right. Now, the use cases of Pig Latin are ETL basically, and you have whenever you have to do a research on data, you will use Pig Latin, and or iterative batch processing or batch processing. Okay, so let me put things in perspective. So you are a data scientist or you are a data developer. You need to operate upon some tools. Let's say you pick up Mahat, for example. You have got a huge data on one end, which is Apache logs, or which is other logs of user behavior, or maybe you have lot of data which needs to be churned. That is one on one end, and on another end you have these nice tools which, such as say you have Mahat or some other image processing engine. They need the data to be in the format that they wish. Okay, they want things to be comma separated, and then things to be in the colon separated, and so on, right? So between raw data and the input required by these nice tools, or maybe you have a nice visualizer which visualizes the data, you need to do a lot of churning and lot of translation of the data. Okay, so that's where pig scripts would lie. Your pig script will take the raw data and convert into something meaningful to various tools or visualizations or graphs. All right, and that's what pigletin will help you to it. And pigletin is pig is basically just a client, and your scripts get converted into map reduces under the hood. Okay, and then it gets distributed automatically. Okay, so there is no server for pigletin. Pigletin uh, Pig doesn't have a server. Pig doesn't maintain a information about your data. You don't give any data to pig, so it's completely absolutely stateless. All right, so it's like a normal client side program which runs on your script, executes it by the way of MapReduces, and makes you happy. All right. So there are a little bit of philosophy about pig. First is pig eats anything, meaning no matter the data is in what format, it accepts it. Okay, whether data is nested, structured, unstructured, relational, or any format, it helps you handle it. Second, pig lives anywhere. Okay, what does it mean? Its pig was initially designed for Hadoop, but later all other frameworks started using it. And the objective is to have pig pigletin as the entry point for the end user, and pigletin becomes the programming language for any big data parallel programming. Okay, pigs are domestic animals, meaning pig is very controllable, very controllable. It provides you streamings, it provides you various kinds of custom functions, it lets you control anything, it lets you customize anything, override any of the functions which you wish. And that is what makes it so powerful, and because it's controllable. If you want to change the way it has to load the data, you can do that. All right. You want to introduce one more function, you can do that immediately. Not a big deal. You want to use Java function, existing library, immediately you can use it. Right. So therefore, pigs are generally domestic animals. Pigs fly. There's a fourth pillar called pigs fly, because pig is designed for performance. Pig is designed for performance because SQL wasn't designed for the kind of. Yes, you can call a Java API from Pigletin. Yes. All right. All right. So you can tell Pig that, hey, execute these many reducers, execute this way or that way. So you will see in the query language that there are a lot of syntax which is introduced in order for the optimization, because optimization really a big deal here. In case your data is smaller, in case your data is smaller, there is not much of a difference between n square and n log n. Okay, if you have a million records and you have to sort them, if your algorithm is one of the worst, it could be in n square. If your algorithm is really good, it can be n log n. And when your data is smaller, n square and n log n wouldn't make much of a difference. But the moment the data crosses beyond a boundary, the two, n square and n log n, becomes really big difference, right? And the time taken goes from suddenly from hours to months, and that's where it hurts. So so it's important for your code to be heavily optimized, because you will realize that your code is doing pretty good on the test data, but the moment it hits few GBs, suddenly you get no output at all. Okay, you're waiting for months. So that is why the optimization is the key pillar in any of the big data technologies. All right. In case of SQL, even if you forgot to create couple of indexes, it's okay in the smaller data. The moment it becomes a big data, the same SQL which was fine without indexes becomes impossible to handle, right? Therefore, when it comes to big data, you need to be very cautious when you are building solutions. You need to think about it. Think about the optimization. And therefore, almost any tool which is built for big data requires it gives you a knobs to control optimization. So pigs fly, pig is designed for performance. Now to install it, it's quite straightforward. So you can just download it, download pig point 13 and copy it into user local anywhere you wish to put it. Okay, because it's just a client side library. Okay, and then export it. Now, after you export this Java variable, which basically you're telling pig that hey, here is my Java, because pig, though being a client side, is still written in Java. Okay. Now, at this moment, when your Java is perfectly working fine, pig minus x local, the local mode should work fine. Okay. But the moment you want to connect to the existing Hadoop installation, you will have to say pig class path equals to the Hadoop configuration file. Okay, etc Hadoop. That's all on each machine. Although if you're using something like Ambari, you don't require to do any of this. It's already installed. There is something called install clients, and it install clients on all the machines. Okay, and once you're done with it, just add pig bin to your path and enjoy. Okay. Now from use, I mean, it should not be much of a problem if you want, if you are really interested to install it. Go ahead. It's not a big deal, but you don't require it right now. Yeah, you need to. You don't here. You have to specify the class path. Where is the config file located for the Hadoop, and whatever in the config file, there will be something called HDFS config. There will be something called your MapReduce config. It'll pick up from there and take and understand the IP addresses. Okay, so this is the only place you need to configure. Export this variable that hey, this is my Hadoop config files. You just pick up the standard Hadoop config file, not something you have to make. Okay. So if you have installed Hadoop on the system, you can immediately start using Piglatin. In case your Hadoop is located somewhere else, install Hadoop client only. And in the Hadoop client, you configure that your name node, data node are located somewhere. Give the SSH permissions. Okay. But that's very very custom kind of installations. Now, yes, it will pick up the config that sites and .xml and will start working on its own. Yes. Okay. So And in case, and you don't require that one too much. What you can do is you can basically, and even if your program is only the client side, you don't even require all the other step after this point. You can keep on running your script in pig local as long as it's working fine. Then you move your script to the server and execute on the real Hadoop. Okay. Here it emulates. This emulates the local MapReduce. So what exactly does it need from config sites? It needs to know where is MapReduce located, where is name node, where is data node, and where is your HDFS. Okay. So whenever we give it a script, it needs to upload that whole jar class file to the Hadoop MapReduce and give it there. Okay. All right. Now for you, you don't have to worry about it. So you can just go to SSH student at hadoop1.no big data. Since all of us are doing together, in case somebody is doing that, you can also try Hadoop 2, Hadoop 3, Hadoop 4. Everything will work fine. Okay. Now, all you need to do is SSH, and there we are. So it says that connected to the file system, and basically it starts to connect to the task tracker and job tracker. Okay. And you can also define your pig bootup script. That's okay, we'll talk about it later. And that's all. Okay. So now it is happily connected, and now we can start seeing it. So all right, now sounds good to me. All right. Also under data folder, you should see that most of the data is uploaded over there. Okay. And data for today's exercises is uploaded over there. And just notice that you can just see that you can execute all the commands with fs. Okay. Right. So you don't need to get out of the shell, get out of the grunt and start doing something else. Okay. Now here we are. So it has got two modes, as we were talking. It has got two modes. One is called pig minus x local. In this, it doesn't connect to Hadoop. It's basically running in a local mode. It's good for testing, and it improves your performance because you are not hitting the Hadoop every time. You are doing it locally. Now, if you do ls, it's actually showing me the local folder. Okay, this is local folder. See? So if you do ping minus x local, it's actually local. File system is local file system, and it's not having a connectivity to the Hadoop. Okay, everybody okay till here? All right. Yes, R1, and this information you see every time you do ls is basically here R1, R1. And right now I've set it replication to 1. I'll be changing it again back to 3. Okay, we'll be changing it back to 3 because there was a lot of data we had to upload. Okay, now moving on. Now, when you're calling pig, the first command line argument was pig minus x local, which was for local. In case you want to execute a script, so all the commands which we are going to show one by one, you can write all of them into a file, and we start calling it script. And the way to execute the script is by saying pig and script name. That's all. Okay. Also, if you want to execute a single command from outside, you can do this. So you can say pig minus e ls, right? So a single command is executed and you are no longer inside a command prompt, right? Now minus version, and you can also see minus h. It shows you the help file, help documentation of everything. All right. So now we're back in the grunt. So the moment we type pig, we could get connected to the Hadoop and we are rolling. All right. So pig grunt, the command prompt of the pig is grunt, and anytime any command you type here is executed. Also, you can do various kinds of things, such as basically do cat clear cat basically type any hdfs file, copy a file to hdfs, copy from local, copy to local, dump, describe. So whatever Hadoop FS provided you is already here. Other than that, it provides you things like kill. It can kill a process in case you are running a task tracker and the process is stuck somewhere. You want to kill it, you can kill it from here. Okay. And all right. So also there's something called exec or run to execute any script from here. So you've already written a script somewhere. You want to execute it again in this command prompt and then see if it works, and then you add some more statements to it. Okay. So the difference between run and exec is run is done basically in a different memory space, and exec is done in the same memory space. Okay. No, so now let's have. Yes. So Sanjay's question is it possible to write mapper and reducer logic using pig-Latin language? Yes. So why did we need to write mapper and reducer is to fit our thinking process, convert our thinking process into Hadoop MapReduce, right? Now we don't need to, using pig, we don't need to basically convert our logic into MapReduces. Instead, we have to convert our logic into a series of for each, series of group by, order by, filter by, all of that. Okay, so you don't require to write mapper reducer using pig Latin language. So you can think of pig Latin as improved SQL, which internally automatically does map reduce and everything. So when we discussed those five problems, you had to convert your thinking process. You had to think in terms of map reduces instead of procedural way, which we did earlier, right? So we had to think in terms of map reduces earlier. Now that thinking job is now done by pig and pig Latin. You describe your problem in terms of order by, filter by, group by, and all those steps. All right. Now, let's have a look at our first piglet in the script. Now we have data at in this folder, and our data is not here. So, okay, I want this file. Okay, I want this file and it is here, and I can say pig copy from local my data into data. Now, if we see here, okay, I'll just stick with Hadoop. Hadoop. I think you have to specify HDFS in front of it. I've not done copy from local yet using copy from local, copy from local, and if I say HDFS and let me try this. Okay, did it copy? No, it didn't copy, and I don't know what did it do. Okay, Hadoop, Hadoop FS, copy from local, and this to, is it so? Hadoop FS minus ls. Oh, it's done. Already done by pig. It just did not refresh too fast. Not really, it's not done. What? Hadoop FS. Strange. What's with this? Why can't I see this file here? Oh, it's there. I've been just skipping this one. Oh, I didn't see in the chat box. Okay, maybe I think I need a coffee shot. Okay, so cool. So fine, we have this data over there already, and we can say now our objective in this exercise, in case you don't understand it, don't panic at all. Okay, here our data is basically New York Stock Exchange data. The first column is the stock exchange name, which is NYSE in our case. Second is the symbol, okay, symbol of each stock, and third one is the date, and fourth one is the stock price. All we want to do is we want to just compute average value of CPO, average value of each symbol. If we are in SQL, what will you do quickly? If you had to do average, if you have to do this operation, if you had to do in SQL, what will you do? Let me have a look. Who can do that? Yes. Anybody else than Shivasant? Good, good, good. So Srivasant and Sanjay, great job. So basically group by and then average, right? And that's what is most logical. And same thing can be done using pig in a way in the same exact manner. Just that instead of writing everything in a single way, you do it step by step. So first step is load the file into a variable called div. Then just check if it is working or not, what is loaded. Then you see explain divs, which tells you a little bit more about data. So these are just for diagnostic, right? This is the next statement, which basically does a group by. We are group by on the second column, which we have given some name here. And once you are grouped, once the data is grouped, we compute the average. All right? We do the average computation. And once we have done the average computation, we store it in a file. Okay? And we are happy. So effectively, the main job is actually done here in these two statements. First one is group by, and then second one is average computation. All right. So I hope everybody got it. Now let's try to do it and let's see how does it look. Okay. So we did divs. Let's see what does say. Explain divs. It tells us that this is what is going to happen. Once you get little expert and try to debug your problem, you should be able to do it. Okay. All right. It says that load this particular file using something called pig storage, and then it will have these columns, okay, in this format. Right. By default, the third column, almost all of them has been considered as byte array. Okay. Now you can, if you have to see all of the data, you can say dump divs and you'll get all of the data. And note that when we say even dump, it is going to do it in a using MapReduce. You can see MapReduce launcher started, 0% completed, and so on. Okay. Why is it stuck? Okay, it's doing the job, and good. So notice that when we said div load, it didn't do anything. It internally noted. It's basically say dump, it's basically printing what it is. Okay. So till the point we said dump, it didn't do anything. It just loaded and made a symbolic representation inside it saying div is essentially a file named this and here it is. Right? It didn't actually load anything. Divs is basically dividends. It's our variable. Okay. This is our name. We can give it any other name you want to have. Okay. So we want to call it divs Vishal, for example. So let's call it, yeah, and then we can. Yes, is dump is just a debugging step. So second is group by. Okay. Now we grouped it by a particular column. So guys, in case you do not understand anything out of it, do not panic. Do not panic. And but do ask questions. We'll we'll be going into details of each of these commands as we go ahead. Okay. So the way to learn any new language is actually multifold. You just see a program, try to understand it, then you go into, first you go into horizontally, look at horizontally, and then you go vertically. So right now we are looking at horizontally, we are looking at the whole thing. And now you say group by, and if you say describe grouped, you can see that grouped is having this group, it is grouped by this, and these are the all columns which we have been grouped by. Then we do for each. So anything which is on the left hand side is your variable. You do some churning, you put your result into this, you do some group by, you put your result into your variable, then you iterate over it, and then and so on. All right. So here, next step is we are going to compute for each and put the result into averaged. Okay. Now, if you see describe f raised, basically has nothing but name of the group and number. Okay. So explain goes into far more detailed debugging steps, while describe just gives us the data types. Okay. Now, if you just want to see the data structure, because here the data can be in very complex format, like here in this one, it's more like a hash table. The key is the group, and this is basically a collection of fields. Okay. Line number 5. Okay. Line number 5 is for each element of groups. Okay, you can think of group as lot of lines. Every line has got a field called group and a value called the whole table, all of the columns. So so we iterate over each group. Okay, for each group, right, for each in this variable called grouped, generate group. Whenever you group something, we'll go into details, don't worry. Whenever we group something, it creates a column called group, and then the rest of it. Okay, so we say generate first field called group, and rest is just do a average computation of this variable. Okay. Right. So by default, pig expects the file to be having the tab. Okay, tab separator. That is Virana's answer. So based on the tab separation, it basically split the file into 4 variables in each line. So each line it expects to be separated by new line character /n and fields to be separated by /t. Okay. Yes, you can define delimiter. Definitely, we'll go into the details, don't worry. And once you are done with computing the average, you can basically say store my output somewhere, and it says file already exists, and let's give it some name, and that is 8n. Now it is when you say store, then it is taking time. Which does it ring a bell? It shows you that when we did grouping or when we said load, it didn't take too much time. It took time only when we said store or dump, meaning it actually is doing the processing whenever we we do dump or store. Okay. Otherwise, we are actually describing things. All right. So what is the scope of these variables? These variables are visible only during one script execution. Okay. So these variables, this is an interesting question. So as long as this prompt is open, these variables are visible. Like we said, okay, now that file is stored. You can see that file, student data out averaged 80, 8n. Okay. Now www.hadoop1, Hadoop1 and 8000, then file browser. Yes, file has gone back to the HDFS. Now there would be a folder called data out. Do you see the data out? Good. And once I'm done with the data out, average dash 8n is what it has. Okay, so it has computed and stored in this file. Looks interesting to you, right? The scope of these variables like store average. Now, if you see describe averaged, it says this, but if I exit the pig prompt and open it, it's no longer there. So describe averaged. Okay, unable to find an alias for averaged. Okay, cool. So that was our very quick overview of the language. Now, right, thank you, Sini, for that question. And yes, you are right. You are right. So, when does it know that when to execute your work? The moment you say store or dump, it understands that it is time to do the execution. It doesn't need to necessarily know the beginning because it knows the operations. Okay, so it has in its memory that hey, this guy wanted first divs means load something, and grouped means group by the divs which he has described earlier, and do this. So it has this all of this figured out. The only question is when does it do the actual work? When does we say that this is the end of script? It is based on the point where you say store or dump. Okay, so either print to the screen or save the data somewhere on the HDFS. That's when the whole process starts. That's when it figures out what are the dependencies, and if these dependencies has further dependencies, and it does the computation from then onwards. Sounds cool. Now this was a very a trailer sort of thing where hello, cool. So yeah, so this load is basically happening from HDFS, and this file which we are talking is small. But if it's a big file, very huge file like hundreds of terabyte, then also it's not a problem because HDFS internally is handling all the chunks, and all of this big script what we are writing as like SQL is going to do the whole execution of all of this work parallelly on all machines. Okay, you're right, Sanjay. All right. Now let's start with data type, just like any other programming language. So just like any other programming language, you have data types, and most of these data types are very similar to what we have in Java. So when we don't specify any data type, generally it considers it to be byte array. So first one is int, second one is long for storing big numbers, then float for storing decimal numbers, and double for storing big floating point numbers, and then character array as in string, and byte array is basically bytes. All right, so that would make you understand that we can actually load a binary data on using pig. Okay, if you have a loader in place. Now, other than these basic data types, you have really good ones, complex data types. Okay, and this is something which is new to lots of us because if you come from SQL background, we never dealt with any complex data type. Everything was a table. Okay, everything was actually converted into tables. So whenever we did data modeling, we converted our complex objects into various tables, right? But here it lets you do these computation, do your operations on the complex objects, such as map. Map is nothing but a key value pairs. Okay, so key is a character array, and value can be any other complex type or scalar. The first screen, these are called scalar. Okay, and complex type is basically a combination of scalars in various forms. First form is map. In map you have keys, and the value can be either a scalar or any other complex types. Tuple is basically a fixed length ordered collection. What does it mean? Tuple is necessarily, you can think of tuple as a single row. A single row, if you have read about tuple algebra, a row is referred as a tuple in tuple algebra. If you have gone through the DB theory. So tuple is essentially a single row containing all these column values. And each of these values can be either referred by index of the column or can be referred by their names. If they don't have a name, you can refer them by index. Okay? Sounds good. And tuple can contain either a map or a scalar. Okay? So map can contain tuple and tuple can contain map. And now you can understand that you can form any kind of very, very, very complex structures of data just based on these two. Right? Now, third form of complex data type is bag. Bag is basically unordered collection of tuples. You can think of bag as a table, or you can think of bag as a data set or row set, whatever you want to call. So basically, bag is an unordered collection of tuples. Okay. What does it mean by unordered? We cannot refer a row by any index or anything. Okay. Whenever you do a set based operations, when you do a set based operations, you essentially say this is a set of these things. There you don't have an index for those things. Okay. And in case you want to be indexed, keep things in tuple of tuples, and that should be good. Okay. Now bag, other than these qualities which we have described just now, that it's like a data table, it's like a bag is basically collection of tuples, it looks like a set, and so on. The most important property that key puts bag aside from other data type is bag does not necessarily need to fit into the memory. Okay, bag is spilled over the disk in case it grows in the size. All right, that is true everywhere. Okay, so tuple and bag, you can think of tuple as a single row. A single row is called a tuple, and a table, database table, is called bag. Now, is it clear, Vishal? Okay. The biggest difference is the last point where, all right. Now, so there we go. In when we talked about data types, do not assume that the data types, the rigidity of data types is similar to SQL. No. Pig is not very particular about the data types. As you saw just now in the example we had just done, if you see the example where, I mean, in the example just before, we never defined the value as integer. We only told that, hey, we have got four columns We have got only four columns. Go and figure out their data type. And when we said average of the value, we never specified that this is integer, or it did not give us error. It automatically figured it out. All right, it automatically figured it out. And that is something smart about Pig. It's not finicky about schema, it's not finicky about data types. It figures it out by itself. Okay, you can either tell it upfront, it'll be good, it'll be thankful to you. But if you don't tell it upfront, you can tell it later on. Okay, same thing what we just did, you can load the same thing in this manner also, where you said exchange is a character array, symbol is also a character array meaning a string, and date is also a character array. We can say that date is, I doubt if date has been included as a data type yet. All right. Yes, it's not that strongly typed. You can say that it's similar to Python with respect to the behavior towards data types. Guys, are you with me? We have 14 people in class and only few people are responding. Guys, feel free to ask questions. And the sole objective of these classes is to be able to get your doubts clear. Okay? All right. Now, so now you can also define your data that, hey, I'm expecting a map here, or I'm expecting a tuple. The way we just did for float, we said dividend is, expect dividend to be of type float. That's what we are telling to Pig. Similarly, we can tell to Pig that, hey, I'm expecting a map, okay? This field is of type map, and you can also say that this field is of type map where the value is of int. And remember, when we say map, key is always a string, okay, that you can't change. While the value is only part you can define. Okay. If you don't define, it will consider it to be byte array, and whenever needed, it will try to decipher its meaning and cast it. All right. And similarly, you can define that, hey, my data type called A, the way we have exchange colon char array. Similarly, we can say exchange colon tuple, that we are expecting exchange to be a tuple. We are expecting exchange to be a collection of values, ordered collection of values. And and you can also say that, hey, I'm expecting a tuple. I'm expecting a tuple where the first one is integer, second one is a byte array, and so on, right? Or you can say, and you can also say, let me just put that one. You can also say this way that I'm expecting, I want to give name to first field as a x, second field as y, right? Now, in third one, the bag is basically, in when you say bag, it's basically a collection of tuples, and the only way to we will be not be giving the name to the positions, just like we were giving in the map. We are only telling in bag that, hey, this bag is a collection of tuples. There is no name to each row, there is no index to each row. Okay, it's a collection of tuple, and my tuple type is this is the data type of my tuples. And we can also write it this way, we can write it this way. If you don't know the data type, or you are feeling lazy that I don't want to specify the data type, feel free to do that. Okay. What is the difference is it going to make? The different ways is number two. Okay. So basically the difference is you don't know the data type upfront. Okay. Or you know that all of it is byte array, right? Also, in some circumstances, your data is not always very cleanly defined, right? So it makes a lot of difference where you're dealing with the data in these points. Okay. So Virana, did I answer your question? So you can cast the data from one type to another if possible. If it is possible, then it will cast it. You can also put a type in front of it. Yeah, defining details versus not. Sometimes you are very sure about the data type, sometimes you are not, right? The other thing is, if you say just the tuple and you don't say anything else, then it is going to, it will not give you the names. So there are two objectives of these things. First is giving a name to each columns, and second is giving the data types also. And you can or cannot, you may or may not like to give the names. It's completely up to you. And because if you don't give the names, it'll become complex in referring these values back when you are, say, instead of saying divs dot val, you'll say divs dot dollar zero. Okay, that will make your code very badly readable. So I think, Vishal, I answered your question. Right. Aw- okay, so moving on. What if I didn't give data type of a column? What if I didn't give data type of a column given it was defined? Okay, okay. Okay, that's okay. It will consider it initially byte array, and also it will do a very educated guess from on the data type. It will digest it. That's why it's called pig eats everything. All right. And another question is, which people ask here. Say I have only said a colon tuple x comma y, but I have three columns. What will he do then? So in that case, it will, you can refer the third column by using dollar $2. Dollar $2 as in 0, 1, 2. That's the third column. In case you don't give it a name, but there is a data, then you can use that. Good, 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 good. So you can call me a telepath. I can figure out. Okay. All right. So that's more about. Okay. So Siva's question is, sort happens while loading data? No. Load is just, a symbolic representation saying this variable called divs is located in a file somewhere. The sort actually happens when you do an operation. Sort is caused by group by, order by, even things like join, they all sort inside. Okay. So your question here is that when we were doing this, when did sort happen? So when did we do a group by? When you said group divs by a ticker, that is the time when the sort started happening. All right. I mean, it didn't happen here, but it happened because of this statement. The moment you said store, at that moment of time, first it loaded file, then did a sorting and grouping, and then it ran for each all over the data and gave you the results. Okay, sounds good. You're going to definitely like this language. Now, each processing result, each processing step results in a new data, and I guess I need to basically move it little ahead. So, okay, so pig's basic construction is that in pig latins, each processing step leads to a new result set, and it's case insensitive, so you can type capital store or you can type small store. All right, and there are multi-line comments just like Java, and single line comments are like SQL. All right, single line comments start with dash dash, and you can always test it by saying so it did nothing. Similarly, if I say this, it done nothing. Okay, the processing is happening on each data node, then where is the data merged? Okay, so let me clean this. So whenever we ask pig to do all of this, what we just did, group by for each, if you think about it, it is going to convert all of these steps into a map reduce and send it to the Hadoop. And the merge and all of this will happen the way it was happening for MapReduce. Okay, if you, because you have done those first few exercises, so the thing which you did is exactly what pig is doing for you. All right, so does that answer your question? All right, now let's take a break for 10 minutes. Break came exactly on 10. And all right, Hello. Hi, sorry guys, I got a little late. Are you guys back? Awesome. Awesome. So there was a question which Vishal has asked. Do we need to worry about the file where the file is stored? No. Okay. That is taken care by the driver, and that is taken care by the basically the catalog. All right. Now we are through with this. So the first syntax which need to be understood is load. Okay. So the syntax is your variable, whatever name you want to give, whatever dataset name you want to give, equals load. Load is an operator which loads this file, right? So this is the most simple syntax saying load my file into this variable. That's all. Okay. And by default, it expects the fields to be separated by slash uh, lines to be separated by slash n and fields to be separated by slash t. Okay, so effectively this will result in divs, which is a bag. Okay, bag is a collection of tuples. All right. So divs is by default, whenever you do this, it expects the fields which are going to be part of the tuple to be separated by tab and each row to be separated by new line. All right. The file name can be relative or absolute. Okay. In our case, we can simply say data slash this. All right. Now, the other format, say your file is not tab separated, your file is comma separated. Then you can put comma over here. Okay. You can say using your storage and say comma. Okay. And it will load the values into. So to load a CSV file, this is the syntax. Remember this part. This will be very useful line. Next one is when you have got multiple file, you can also say load all these files. Okay, by using the wildcard characters. Now, when you want to load the file from HBase, you can use another storage called HBase storage. Okay, NYSE dividends using HBase storage. So this will think that NYSE underscore dividend is a table, okay, is a table in the HBase. All right, this is how it works. Also, whenever you are loading the variables, you're loading the data using any of this syntax, you can also specify columns like this. Okay, and here you can define the data type upfront or maybe later. Okay, what parameters these this will take? Whenever we say okay, HBase, right. So HBase storage you will have to define which namespace you are in inside HBase because there is a concept of a database inside HBase, and then you might have to give the connection properties if required. But generally you don't because whatever login password or whatever authentication you're using while using Hadoop, it will be the same one. Okay. So, all right. Now, good. Now, the other thing which we had already discussed was explain a data set or describe a data set. When you say, so this was load, the next thing you would do is after defining it, so what is the data type we don't use explicitly? So generally the data type which Pig gives you is byte array. Okay. And whenever required, it will cast it. As you can see, I'll show you this. So if I do this, let me just show you this. That will also tell you how to use. All right, now let's have a look. So if you say describe dataset, describe divs, now it will show you the data types. So it says schema of divs is not known. It doesn't know anything. And still, if you if you say group by, and it will still work. Okay. So if you say divs x equals for each divs, and if you see, let me open this up, and I say generate, and I say dollar. So sorry. Okay. If you see dump x, okay, and in this one, if we don't define this data type as we had done earlier, it'll call them byte array. Okay, and while execution, it will try to figure out their data types. Now see, when we say $0, it basically gave us the first column only, right? This is how you refer to the columns. Sounds good? And in case, okay, now we said, now let's have a look. Describe X. So X is byte array, right? Even though we have not defined anything. Now, if you say explain X, right? Now explain X is the complete query plan. Okay, what is going to happen inside it? That's what is described over here. All right. So it says that it will first load, and then for each it will project this byte array zeroth column, and then it is going to store into something called a fake storage onto the UI. Okay, so that's how it is. So describe and explain is effectively, describe is the just gives the data, and explain gives you the detailed plan. Now, in case you happen to be a regular user of Pig, you would actually like to have these plugins for highlighting the syntax for various editors. All right. Now, the next one is store and dump. We'll talk about load. Now we're talking about something called store. Store basically stores the data to a file or any other storage. Okay. In case you want to store your output in tab separated format, then you don't need to specify anything. Okay. Now, if you want to say store our x into x.txt, let me, okay. Okay. Store. x into, oh, I have to put quotes for the file name. Okay, so this will store our file onto HDFS. And in case you want to store it comma separated, you can just say using pig store comma. All right, it's the same thing as while we loaded a comma separate file. Dump prints it on the screen. It's useful for debugging and useful with the script that redirect output. And the easiest way to do it is using dump a variable. Okay. So we can simply say store my file into process this file and using this. Okay. Now, so let's say if it is stored somewhere. So we have x.txt over here, and we can say cat x.txt. And all of these commands, remember, are running on HDFS. See, quickly give us the single column output. All right, so there we go. Now, to iterate over any data, the way we just iterated and we just picked up first column, it's you use for each. For each is like your record by record iterator. Okay, so we say for each grouped. Okay, or even without grouped, you can actually do for each just like we did. I'll show you this. So we said x equals for each dividends generate $0, which means pick up the first column and put it in x for all the rows. That's all we did. Okay, is there any option with pig to query on a GUI like Hive or Hive? So actually you can go into here and say pig. Okay, from there you can actually query it. All right, you have to give a title and you have to go. So this is what people had been already writing. Okay, so you can also do it from there. Right, if you are not able to SSH, you can use it here. All right, just don't delete anybody else's work. Everything is okay. Just give it your name and then put your script. Now, for each basically iterates over row by row, and whatever you want to do with it, you can do that. Okay. For each is more like it under the hood generates various mappers which run on various machines. Okay. Now, here for each basically generates. So Siva's question is there a performance advantage? Not much, not much. But it's actually a good advantage in case you do it upfront, because when you are, I mean, if it happens during load time itself, it's good. In case there are multiple people using the same data type, so there might be yes performance implications. Okay. So for example, there are multiple nodes which are multiple average you are calling. Say you have, let's say you have this and this. Okay, so there are these two things, average one, average two. Every time you dump averaged one or average one, it is going to go and figure out the data types of this value, and then it will try to cast it into integers every time. both of these, whenever both either of these things are done, because both of them depend on the single div, right? So every time if averaged is executed, group will get executed, divs will get executed, and so on, right? Therefore, therefore it's actually advised to have a clarity on data types upfront, but it won't be too big a deal, okay? But as a good practice, it is nice to have that, okay? Now, good, good. So for each is clear to all. We'll go around. I'll actually delete this. I don't like this because it's just unnecessarily complicating things. Okay, let me just say that we don't want name in this. All we want is ticker and we want value. That's all. We don't want anything else. So this will basically generate the ticker and not the other values. Okay, say ticker and value. Sounds cool. So this is clear to, is it, just raise your hand in case it's not clear now. So basically we wanted only two columns. So we just iterated over the row and said only generate these two. Okay. Should I move on to next? That was for each. In MapReduce, we are seeing average was not a good example for it, but it seems to be taken. Yeah, that's a very good point, Vishal. So average was not a good candidate. Average was not a good candidate when we wanted to use it in the combiner. Okay, combiner as in the method that runs on each of the node before merging. But otherwise, average was okay. As a reduce function, Hadoop was fairly okay with it. Okay, so I'm sorry with this. Right. So Sanjay's question is, so here why I have put, I've removed the old syntax and kept this is so that you don't look at the group by right now. So for each doesn't necessarily need to follow group by. Okay. It is an independent entity which runs on a bag. So divs is a bag, it runs on a bag, and for each tuple you can manipulate the tuple and it results in another bag with a different tuple. Okay, sounds little technical. Okay, so this is one set of tuple, this is a bag containing lot of tuples, and this is the the new tuple of this new bag which we are creating. Okay, so or in very simple words, we are sort of creating a table containing only these two columns as a field. All right. So whenever I say bag, you think in terms of table. Whenever I say tuple, you think in terms of a row or column or f- col fields of a row, columns of a row. Okay. Now the other little complex syntax for each is here. This was like fairly simple, fairly simple. And now the other one is you can load the file by specifying various fields. One is this. Second is you can also generate, sorry, this is the load function common for all, which is going to happen at the bottom. Now, the first way where we can actually generate any mathematical value, just like we do select close minus open from my table. It is exactly that way. All right. So the way we used to do, select this or this and this plus this minus this multiply by this. So all of that is called projection. Okay. So for each is essentially doing the projections for you. And you can say close minus open. Or in case you don't know the name and you have not given a name, you have just done till here, then you can say $6 minus $3, and it is fairly acceptable to it. Okay. And even if you have done this, then also the syntax is completely valid. Okay. So in case you don't specify the name of the columns in a row or name of each fields in the tuple, then you can refer them by a positional identifiers. Positional identifiers is in $6, $3. Okay. Now you can also do is for each prices generate dot dot and open, meaning this is equal to saying all the columns before open. Okay. And next, so if you have hundreds of columns and you're feeling lazy and you want to basically say that all columns, okay, till open, that's all we want. Okay, which means exchange symbol date open, right? Now if I say all the columns starting with open and close, then we can say open dot dot close, both are inclusive. All right. The syntax is fairly cool with it. In case you want to select few columns out of the whole thing, for each plays a big role, or you want to do some computation. All right. Sounds good to you? For each basically iterates over the data and does not do any kind of grouping or sorting or anything else. It's like writing a mapper which does nothing but translates the data from one form to another. It does no summarization, no statistics, no reduce, nothing. All right. Now, can somebody guess? As we talked earlier, that in pig, we basically pig essentially converts anything you want to do into a series of maps and reduces. So if you have this pig command, gain equals for each prices and generate close minus open, how many reduces is it going to generate? Quick. 0, 1, 10. Why? Why do we need reduces here? Is there any summarization happening? See, it doesn't have any reduce per se, right? It is like if you had to do it programmatically yourself, you will write a mapper which will take the row as the input and will print out the output as such. It will not write any kind of a reducer code, right? So therefore, there will be no reducer at all. And you can run it and check it while it does the job. It shows you that what mapper and reducer is being created. Okay. Uh, It just so happens that it doesn't generate the source code. It basically creates these, you know, how should I say? Basically, it doesn't basically write the mapper reducer code. Instead, how should I describe it? It basically assembles a jar without exactly writing the map reducer. Otherwise, I could have shown you that it doesn't generate. Okay, try looking at when you do this. Okay, so here there was okay, I need to look at it. I think I know where I've seen what are the maps and reduces being happening. It shows that one map reduce job is running and starting to process to move generated data, and timeline addresses this. Instead use default file system. Total input path to process is 1. Okay, number split is 1 jobs. Here you can see. Oh, sorry. Just above this one. All right. Here you can see. Okay. So first one is job ID. Maps is 1 and reduces is 0. Sounds good here. So first one is job ID, second one is number of maps, third one is reduces. So you can see that there is only one maps and there are 0 reduces. Sounds cool? All right. From previous classes, output underscore files equals reducers. What if there is no reducer, like in this case? So there will be, when I say reducers, right? Meaning, are you writing any logic? Are you writing any logic in the reducer code? Okay, or is it just default collect and save? Okay. So by default, if you don't specify number of reducers, it is going to have only one. Okay, so thank you for letting me know that there might be a confusion. Okay, cool. Now I have got cool. So Vishal just tried by himself the the command and he's able to see the map reduced done for it. Awesome. So Vishal, you can actually share it with all. Okay. And all of you also try to do all of these things by yourself. Only then it will make sense to you. In case of no reducer, does the data automatically go into HD? So when we say reducer, right, I'm actually referring to whether Pig has written any reducer code or not. If you don't specify any reducer code, Hadoop has its own way of collecting the data and saving it. It's just that it won't pass it through a reducer. Okay? But it will collect it in the same way and store it properly. Naveen, that was I was trying to answer your question. Is it possible that we have one reducer but multiple? Yes. So that is when I say that, okay, I think I should modify this question. So, will it have any reducer code generated? Okay. So, Madhav's question is it possible that we have one reducer but multiple of five? That's a very good question, actually. So, even if you have a single you have no reducer, you have not defined any reducer, still you can say that store my file at keep my file, mm, yeah, keep my output in multiple location. Okay. And on what basis is it going to split? That's another problem, right? So again, it will be on the basis of the key, and the default behavior will prevail. All right. All right. Good, good, good. I'm having a great set of team here. And now, so this was about the for each in a simple manner, the projections. Now let's have a look for the complex types. Okay. Now in the complex types, same. Now the let's remove this. Okay, we have only this one. So here we are saying, now let's have a look at our baseball table. So far we have not discussed anything about the complex data. The only form of complex data we have seen is in the form of bag. Now let's have a look at it. So we say tail. Tail is not there. Does it have head? No. So let's have baseball. Cat data slash baseball. Cool. Now we have this. So there is a file called baseball. I think I should open it over here. Then under this there is a data and there is baseball. Okay, let's have a look at this one. Okay, now so here the baseball file is a little complex. Don't get intimidated by it, right? And let me just format it properly. All right, so baseball has first field as the name of the person, then the team name, okay, and then he played as a catcher, and these are the attributes, okay, these. So let me just keep one field in a, so okay, and here we have a hash. This is the map, okay. These are the map of the various scores this person had in past. Okay, so basically this is data of a baseball team. This is the data of the baseball team, and what we have is the name of the person, then the team name, then the trait. These are the character traits of the individual. He's a catcher and he's a designated hitter, and rest of it is the batting history of this person. Okay, he has played these many games, he has hit by pitch this much. This is basically a map. All right, and this is what, quickly somebody, what is this? Tuple. Excellent. All right, and All of these together form a tuple. I'll show you what do I mean when I say this. Okay, look at this closely. So b-ball is essentially a collection of this tuple. And what is this tuple? It contains the first one as name, which is a string. Second one is team, which is a string again. Third one is another bag. And fourth one is a map. All right. Now let's load it. Now if you say describe b-ball, so b-ball is essentially this. Okay. Let's say dump b-ball. I think it'll give an error. Should say file, yeah, file not found. Yeah, it's file not found because we should put data in front of it. Our data exists in this folder. All right. Now the next step is while you do a for each, right? So in case your input contains a tuple, you can basically say t.x, t.y. Yeah. Load is executed when we do a dump command. The whole thing actually starts then. This is something which is very, very different from what we have seen in past. All right. So this is what it is. Now, say we want to do a for each on baseball players, and we can refer to the refer to each of the individual values. Okay. So correct this one. Say for example, bag is there. Bag is, where is my, okay. So where did it go? Yeah, here. Here essentially we can say, what was the command did I execute before this? Yeah, the field name was traits. So under traits there is only, okay. So we can say b equals, basically what I'm trying to say is that inside here our bag does not contain many value. If you say describe b ball, it doesn't contain, it contains only one uh, field in the tuple. Okay, so there I can say for each b ball, okay, and say generate traits dot dollar zero. Okay, and we can say traits. Dumpty. Strangely, all right. So basically, we can generate this We can basically pick up only few values from tuple. Similarly, if we have got a bag like this x and y, we can just pick up one of the values, just like the way we have described it here. Okay, you can see this because this whole thing is considered as a single tuple, and that's what it has outputted. Okay, now the other way of projecting a bag is using these techniques. Okay, what do you mean when we you say load command is executed when we give dump command? So when you say load X, it's not really reading anything. It's just noting down that hey, this guy, when we say b ball equals load baseball, b ball is essentially a plan. It's not really the content of the file. All right. The actual game starts happening when you say dump. It may or may not load the file as is, right? Does it make sense, Naveen? Because it doesn't mean, if you think about MapReduce, loading a file doesn't mean anything. Nobody is going to load the whole file into memory. Instead, we are operating upon a file, and we will talk in terms of if you think about pig, it's internally actually dividing into multiple nodes, and on each node this file is into chunks, and each one is executing the code in terms of mappers, right? So this is how can we print this console output of dump onto log. Good, good point, Srikant. So that is why what you do is you say dump xyz, right? And that is why, right? So what you do is basically pig minus e, and then you can say dump xyz. But before that you need to load it. You need to say xyz equals load xyz.txt, and then you can say, all right. Now this will basically dump it onto the screen, and if you want to save it in my log, then you can save it. Shrikant? Now it's running, and then you can get this all of this information. Okay. Also, all the error logs are saved already into a log file. Okay. So yeah. Now the next one in the pig is here. So every time you execute it, the file is every time you run dump or store, an execution is happening. Only then it creates a log file. Okay, it's a generic for the whole batch. It's not necessarily for a single command. All right. The other things which I have missed out here, when we say load this, as we can specify this, and when we can do for each, we can do all sorts of mathematical operations. Okay, and the operations which we can do are also available onto this exhaustive list of functions, and there these are the eval functions. Okay, not this, we say Okay. Okay. So we can say square root, or whatever we want to say, we can say in the generate function itself. Okay. Here we can say, instead of this, we can also say sqrt of this. All right. Just like your select command in SQL. All right. So you can go into the detail list of the functions, and now now the next command after the for each, we talked about load, we talked about dump, then we talked about for each. The next one is filter. What does the filter means? It is like a where clause. So for each was like your select clause, and filter is like where clause. And so we say that load load my divs. Then next one is, this is important, filter divs by symbol that matches this, right? What does it mean? It means that we are loading the file into using this filter into this. Okay. So it will it will only give out the records where symbol is matching with this regular expression. Okay. So who doesn't know about regular expression? Quick. So everybody knows about regular expression? Yes, no. Oh, great. Great. So all of us are know about this. So what does it mean? What does this line mean? Okay. Sini doesn't know. Sini, you should. Did you receive my email with the regular expression video? If not, I'll send it again. Okay. Go through that video. You should get your answers. Most of your answers. Okay. So right, right. So yes, you guys are right. So so anything that starts with CM is what it will get. Okay. And now similarly, filter divs by not symbol matches this. Okay. So all those symbols we do not which do not match this pattern will not be listed here. So when we say dump, uh, all the rows which did not qualify this criteria will not appear here. Okay. Similarly, you can also put and you can also put or in between, and you can combine them together to join this. Okay. So this is filter is quite important, but good part is that it is exactly like the way we have studied. These are exactly like okay, right, right. So Shrikant, if you think about it, it's actually difficult to form using this here. Okay, try doing that. I would love to see the regex. No, you can't specify the filter while loading, because it doesn't make a difference, because when you say load xyz, it's not really loading, it's basically representing it, so it doesn't make any optimization difference, right? Now that's filter. Now question to you is, do you think will there be any logic generated for reduce code when there is a when you apply a filter? Okay, again same question, how many reducers, as in will there be will there be will there be any reducer generated? Yes, there won't be. The answer is no. All right, answer is no. There is no aggregation function, exactly. So you go from end to end, and yeah, you're not doing any reduction, you are not doing any summarization, you are not doing any aggregation. All right, now that was it. Now now other than that, so that was our filter. You should go into the details about, although everything you can think about, and or not, all of that works well. Okay, in case you have more questions about functions, you should have a look at it. Okay, now the next one we are dealing with is order by. Order by essentially is exactly the way you think. Order divs by symbol and dividends by descending order. What does it mean? It will order the output by the symbol, which is ascending, and dividends by descending. So ordered will contains the records which are ordered first by dividend in ascending as in increasing order, and dividends by descending order. Okay, sounds good. It's exactly like SQL. Similarly, we have distinct over here. We have distinct over here. Distinct, what does distinct does? Distinct gives the distinct values of the field. Okay. Now you say that for each generate only the symbol, and then you say unique symbol and then dump this. So it will only give you only the unique symbols. Okay. Any confusion here? I'm uh, going a little faster here because I am assuming that you are clear about it. In case you are not clear, then just raise your hand. I mean, just ask the question. Okay. So when we say distinct symbols, how many reducers will it generate? Or let me ask, will it generate any reducer code? Yes. Answer is yes. Okay. All right. Here also cool. So that was about distinct and order by. Okay. Now, joining is little different than SQL, but it's pretty good. So you can join based on a single key or a composite key. Joining essentially means we are putting the row of the first one and the row of the second table. We join two tables or two data sets, and which essentially means we take the one row from matching rows from both the tables and form the total columns. Okay, so if there are two tables, first one containing three columns, second one containing four columns, so effectively the output will contain how many? 3 plus 4, 7 columns. All right, that's what it happens. So if you see here 3 plus 4, so even the keys will be repeated on which you have, on the basis you have joined, that will also be repeated. That's your question, right, Vishal? So let me just go into page again and say cd data. I think it works. Yeah. And then I'm trying to join it and say how come this file doesn't exist? That's news to me. Okay, so we have, yeah, again that file has been deleted. Again, it is there in the data folder, and I can say copy from local. Oh, cool. So it actually works. I am using it for the first time, and this seems to be the most cleanest syntax. Okay. To copy the data from local file system to HDFS. And when I say local, local means hadoop1.nobigdata.com. Okay. Hadoop 1. So now let's try to do the same thing again and see if it works. All right. So if you see, this one has how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now what is the error with it? Oh, okay. Now describe daily. Okay, so daily has these column, and I say describe divs. Divs has some columns, and now when I say describe giant, it has all the columns of both the tables, right? From first one starting with daily till the point, where is it? So daily, all the columns of daily which are prefixed with daily here, can see till here, and then divs, all the columns. Okay, joined essentially contains both the columns. exactly like we say select a comma b. Not, I mean, we have, when we say select a comma b, we get all the columns, right? So similarly, we can join the two tables based on this, and that also works well. All right. And now the next one is self join. So self join doesn't work the way it works in SQL. Okay. For self join, you'll have to load it twice. Okay. For self join, you'll have to load the file twice. Same file, if you see div1, div2, the same file is being loaded and you can join them. Okay. So joining essentially means take all the rows from one table, take all the rows from second table where one particular field's value is same. So when we say join daily by symbol and divs by symbol 1, note the name can be different or name can be same in both the tables. But still you'll have to tell that which column from which table. Alright. So that is how the join works. Now you guys can do the joining. The next step in pig is limit and sample. Limit is nice, everybody understands it. Right now we had been struggling most of the time with seeing so much of data, so we can say daily 10 equals limit daily by 10, limit daily 10. And we can also say divs 10 equals limit divs 10. Okay, these are just variable names, divs 10 and daily 10. You can keep them name as much as you want. Now if you say daily, okay, so basically it will show you the only 10 records. And in similarly in this another case, good. Siva, just Siva's question is, there a left or right join? Yes, there is left or right join, and we'll discuss that around 10 slides later. Okay. Okay. So still it takes a little bit more time because it is going to load and do all the process. All right. Now limit basically gives first 10 records. That's all. First n number of records, whatever you specify over here. Those are the only 10 records you'll see. Similarly, we have sample. Sample is something interesting which is there in pig, which is not there in SQL. Sample basically gives you 10 different records. Sorry, sample essentially gives you different sample from a big file. And you can specify the ratio, the proportion in which you want. Point 0.1 means 10% record, 1/10th record of the total one you will get in the sum. Okay, and every time, so essentially any random 10 records you will get in this, every time you sample you get 10, you get a small sample of the whole data. Okay, now you can see the limit actually works well. Now out of these records, the way we have done is we can also say sum, and we can say, so, and we can say sum equals sample divs 0.001. Okay, and when we say sum, let's see what happens. All right, so that is how. Now if you have this, and if you have this command called sum equals sample, and you have done dump sum and dump sum, right? So will these two dumps, will they result in the same value or different? Anybody? Srikant says different. Anybody else? Different. So Sanjay, you have said both the things. You have said same as well as different. Take only one side. Different or same. Cletus is saying different. Good. 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 Yes. It will give different results every time. Okay. So even though we are not loading it again, we are just dumping it again. It will lead to different records. Here we got this one, and let's see what happens this time. Okay. As we said, whenever we do dump, only then the things are evaluated. Therefore, sample will be evaluated twice because there are two dump. All right. Okay. Sounds good. You can think of now earlier we got this record and this time we got no record. Well, that's nice. Yep. Okay. Okay. So everybody is clear till here. Okay. Let me ask you, who doesn't have the clarity now? Anything? Did I miss something? Did I jump over something? Or did I not explain anything improperly? Yes. So the general way of doing all of this is you guys should actually log on as I'm doing and you should try it out. Okay. Okay. Point. Let me go back once. Yeah. So factor is basically a ratio. Okay. So if New York, this record has this New York Stock Exchange dividends has 100 records, sample will give us 10, 1/10. Okay. Any 10 records it will give us, but random. Yes. Random sample. That does not mean that it will give you a random output. Okay. Let's show this thing where we has print first 10 and print means dump. Okay, we had first 10, right? And say sample. Okay, sample is sample first 10 and say 0.5. So dump first 10. Okay, Sanjay's question, for example, there are two same symbol in one file. and in another there is one matching symbol only. Yes. So right now it is basically when you are joining, you'll get two records from total two records. Awesome. It's doing something. Yeah. So basically what I'm trying to explain here is sample will give a random sample of things. Not necessarily that last record will become first and first will become last. It will not shuffle it randomly. It will just pick 10 things out of it. It will not shuffle it. Okay. Okay. So Siva's question is that how random and limits are converted to MapReduce. You need to think about it. Let's say you had to give 50% of the total records, right? So you pick up first record, do a coin toss. If it comes head, you let it go. Pick up another record, do a coin toss. If it comes head, then you let it go. Otherwise, you drop it. So this way, you will generally end up having 50% of the total records. But this is statistical. It's not guaranteed to be 50%. As we had just done that when we did 1% of the total record, once we got one record and the next time we did not get any. Okay? So this is a statistical one. If you are unlucky and your coin is really biased, you might end up getting nothing, even though you were supposed to get 50% records. Did I should I explain this again? How does the random works? So say you had to pick up 1/6 of records. You had say 6 million records and you want 1 million record, right? Now what you want is you want 1 million records out of it, but these to be randomly 1 million. Okay. Now we pick up this time instead of taking a mm, coin, we take a dice. And every time we pick up a record, we throw a dice. In case we get, say, 1, we let it pass. Again, we throw a dice. In case it comes 2, we don't let it pass or anything other than 2. So this way, we are able to statistically pick up 1/6 of records. Okay. Now, Naveen has got a good point. What's the point of a sample then? Right? So, sample is not really limit or optimization step. It is essentially for giving you a random set of data. It's required in a lot of cases. It is required in lot of cases, lot of test cases, and a little bit of a statistical analysis you need to do. In those cases, sample is actually quite useful. All right. So, so sample is basically if you have got huge records and you just want to churn 10 records, any 10 records. If it doesn't return no data, then you are having really, really bad luck. Okay. I got no data because 1% of the total records was one record actually. Okay. There were 100 records in that file. All right. Cool. So we are with good. We are doing good. Now we are done with limit and sample. Now again we are done with this. Yep. Now we will discuss from parallel tomorrow, right? Till then, go through the exercises mentioned on the our page. Okay, mentioned on the page. We have got 5 exercises, though we are into moving into a quiz. So let me just, so session number 5. Okay, so this is the old video. Okay, previous classes video I have put there, and not this one. I wanted the assignment. Okay, this assignment is fairly simple. You should be able to do it. Basically, you are given tweets. Okay, tweet has got 3 columns: tweet ID, tweet message, and user login. And as well as you have got users. Okay, download this file, and you've got users, username, state. Download it again. Do not worry about the space consumption on the Hadoop. These are small files. Now, first question is, give the login of all users in New York State. Okay, you see the state here. So you have to give the user logins of the people who belong to New York State. All right. Second one is, give the all the tweets. This is the tweet message, right? All the tweets containing containing the keyword called favorite. All right, keyword called favorite. Now, third question for you is, now do the MapReduce program that does a natural join based on user login. You have to join these two tables based on user login. Okay, third column here, first column here. You need to join these two tables on basis of the user login, and you have to do this using MapReduce algorithm without the pig. I want you to feel the need of the pig here. It's very important to understand that part. So to join this, you'll make this as the key and the whole table as the value. Similarly, here you'll make this as the key and the whole table as the value. And then uh, in the reduce, you will just combine these columns. All right. Now, fourth question is, Sim- similar to the third point here, joining, do the same thing using pigletting. The expected output is this 6 columns. Okay, do the joining using pigletting. Now, next is write a pigletting query that returns number of tweets for each username, not login. Okay, you should output one user per line in this format. Okay, and here you have to order them from most active to least active. Okay, here I am not expecting you to write 0, uh, not expecting you to provide the users with 0 number of tweet. Okay, and these last 7 and 8 you can do it tomorrow. Okay, but these first 6 you can do it right away. It will take couple of hours, maybe at most 1 hour actually. All right, so go through these questions and try to solve them. All right, we'll be providing very quickly, we'll be providing a quiz kind of a format where you can write in a big text box on the website itself. Okay, but till then you can even write all of this in email to me. Okay, sounds good. So carry on, finish all of this, and let's meet tomorrow. All right, make sure that you learn how to use pig very efficiently, because that is what is going to be used by you for quite some time. All right, you will definitely start liking it. Good. Great. Great, this was a great discussion. Yes, Vishal, just drop there's an email so that I can reply to all the people. Okay. Vishal's question has some question regarding limit and sample. So think about limit. How would you implement a limit using MapReduce? Okay. So remember that while you are thinking about limit, you can think about when you have MapReduce, you create a class, right? And that class has got created only once. All right, guys, have a great day. Bye bye. Good night.